Hello, everyone. I'm Noor. Well, I'm CEO at GT Unlimited, but the work I'm going to talk to you about today is basically the work I've done during my PhD and postdoc and professorship at Aalborg University in Copenhagen. And it's mainly about modeling and understanding users' emotions, users' affective state when they interact with digital mediums. And I believe this is an area where computers versus the other areas has been doing quite poorly in. So this kind of a controversial area. So understanding and modeling player. Basically, I'm going to talk of understanding players' emotions, so not really like general users, but more of like players when they interact with digital games. So I'm going to talk a little bit about motivation, the problem that we're trying to solve and why it is important. I'm going to give some examples about the work that I have been done, some of the games that we have been studying, and finally, conclusion. I will start by introducing two terms that I'm going to be using quite frequently during my talk, and those are player experience and player experience modeling. Player experience is usually the emotional states, the affective the cognitive signals that comes out of the users when they interact with the digital medium in general. And in this case, in this talk, it's going to be about when they interact with the digital game. Player experience modeling is basically trying to understand, trying to figure out what function or what functions maps these emotions to the content that they have seen. So if you play a piece of content, you kind of experience some kind of emotion, and that relates to what you have seen in the game. Is there a way to find a function that maps this information, what you have seen, and how you felt about it? And if that is the case, then we can use these sort of functions to do many things. One of them is, crucially, personalization. Come up with new pieces of content that maps your emotion, that are personalized according to how you feel, trying to optimize your experience. So again, I'm going to talk about player emotion, which is like the kid playing computer games, but the same principle applies to many different other interactions. So whether we are interacting with a robot, whether you are interacting with your mobile, whether you're talking to Siri or Alexa and how they respond to you, whether they can figure out how you're feeling and kind of come up with like more emotional aware answer. So yeah, here we go. So why we are doing this? It's mainly because we are independent, we are individuals, and every one of us is different from the rest of us. We experience different things, and we express our emotion differently. And computers right now are still very, very insufficient. They are ineffective in capturing these emotional states, in capturing how we feel and responding in a meaningful way. Oh, sorry. There are more and more information coming from the users, either in terms of like from our interaction with digital mediums. Everything is usually collected. We have like cameras. We have, in terms of like when you're playing games, like we have streams coming in from your actions. Everything is recorded, and we have the wealth of this information, but we are not yet in the state where we are using it fully. So we want to kind of like use this information to better understand players. And finally, as I said, personalization does not only benefit the user, which is like you as you're playing the game, it also benefits the designer in terms of understanding their customers, understanding their users, and coming up with better content. The main fundamental issue here is like finding this function, or whether it actually exists. Is there a function that actually maps how we feel and what we see, how we experience the game? And our approach to it is basically to capture as much information as we can, to crowdsource the data that is needed to find this function. So collect as much information as we can and trying to find out patterns, find out functions that maps emotion into content. So we start by crowdsourcing player experience. And we have done that through experiments done on hundreds of players, basically, playing 4 different games. You might recognize some of these games. The first one is the old-style classic Super Mario Bros. Then you have a variation of the Pac-Man, a car racing game, and a first-person shooter game. So about how do you capture experience, how do you capture feelings, how do you capture actions, emotions? We've done different things. One of them is subjective measures of experience, where we basically ask people about how they feel about the game, whether it's ranking, whether it's pairwise conversion, we basically ask. The more trickier part is to measure emotions, like indirectly using objective measures. So you basically plug in wired like to the brain, to the skin conductance, heart rates. You do gesture recognition, you do image recognition like facial expressions, eye gaze, these kind of things. So we kind of had a collection of all of these measures for the different games that I talked about. More crucially, you need in-game data is usually the easiest to collect. So how you basically play the game, how well you did, what's your playing patterns, how do you press the keys, how fast you do it, and all of these kind of things. What do you prefer and what you don't? What do you pick up? What were the things that left? How good were you in killing animals, and how do you interacted with them? This is actually a picture from Prince of Persia, my favorite games ever. And well, you have all of these data, and you need to find the function. You need to figure out if there's anything hidden in the data that could tell you something. And you could do it also in different way. One of them is to kind of have one modality of information, one modality of input, which can be only in-game behavior, only skin conductance, only facial expression, and you try to map those into what has actually been going on in the game, what you have seen. The other way, the more kind of accurate way of doing it, is to have a number of modalities. So like all of these modalities coming in from the users, and you try to sync them, put them in the same kind of timeline, and then link them to the content that has been presented and find a map between the two. So I've been doing both. This is an example from a player playing Super Mario Bros. Yeah. You see, she's quite emotional. You can tell from her face whether she lost or wins, or whether she was happy or sad. But I wanted to point out that this is rarely the case. It's very different depending on your background, depending on who you are, depending on your expertise in the game. And you need to take into account all of these factors, all of these attributes, if you want to measure player experience accurately. You need to cluster players. You need to understand your population before actually coming up with the generic function that maps emotions into content. So to the modeling part, what we have done is that we try to analyze their facial expression, what has happened during the whole game, and how the content reflected into facial expressions. We take that, we take also in-game action into account, and we train machine learning models. We basically train neural networks, we train random forest, multivariate regression models, and we try to find a mapping. And what you get is something like this. It's kind of like, this is a simplified version of what you get, and in this case, this is coming from a random forest because they're basically more expressive than neural networks. So you get to learn what is important for each emotional state. So this kind of the features that have been selected or linked by a random forest to be correlated with high level or low level of challenge or engagement in this case. And you see that there's certain features that are kind of more important, more significant when studying specific emotional states. And these are different if you cluster players first and then you build in the models, which is kind of obvious. So what we wanted to do next is to check whether there's correlation between the player playing two different games. Because as a player, you are still the same person, whether you're playing Super Mario Bros. Or whether you're actually playing a first-person shooter game. So there should be some characteristic of you as a player that scales from one game to another, even though the games themselves are quite different. So we wanted to find correlations between the feature within these two games. And it turns out that actually there is such features. They might not be super obvious or self-explanatory, but there are such features that kind of scale across different games. So it's not usually the case that you have to collect data sets, new data sets for each game in order to model player experience for that specific game. If you have one game, you collect data, and then you want to design a new game, then you can basically reuse some of the information that you have built before to build in or to design your new game. And that's basically scale for every digital interaction. Can we play this? OK, cool. So from this kind of models, we built a tool called Visby. And the whole goal of it is to kind of put player experience in a more visual visually appealing way so that designers can interact with it. So the models that I've been talking about before, kind of the output from them has been projected into this interface where you have a scale for engagement and a scale for challenge, and you have player experience projected on these two scales. So if you want to say sample from highly engaging, highly challenging instances, then you basically pick up these like instances from that area, and the interface will instantly create new content that is of high engagement, high challenging for a specific level. So you basically play a piece of content, your data will be collected, your player experience kind of model will be created and will be projected, and designers can basically interact with it to pick up the right experience for you. Or you can, as a player, interact with a tool. So here's a different player, a different landscape for expressive space. You can pick and choose from this space. You want like something that is highly engaging, highly frustrating at the same time. You can click generate, new instances will be creating of high engagement, high frustration. You can create as many variations as possible. Low engagement, low frustration, different variations, different styles for the content. In this game, it's going to be like, there is a number of variables that are linked to the number of enemies, the width of the gap, and how many gaps there are. So basically how difficult the level will be perceived if it's played. Then you can play the instances, new data will be collected and feedback to refine the models, and a new experience will be projected, and so on. Skip this. So in conclusion, what I want to say is like, there is actually a function that maps our emotion. Whether this is like, it's kind of a contradiction thing, because I mean, you could argue that emotion cannot really be explicitly like explained as a mathematical function, but you can somehow approximate some factors of emotion in like a neural network that's basically a mathematical function. And you can capture something about emotion with that. So whether there exists something or not is not really important. What is important is we can accurately measure something using neural networks, and it has been working so far. So why not use this information? Why not use this tool to model emotion, to come up with understanding of emotions, and use this information to come up with personalized content, to come up with tools, with digital content that can better understand us as a human. Multimodal input is always better than single input. It's more tricky to work with multimodalities, but it always gives higher accuracy, and it's obviously harder to collect as well. There's usually kind of a trade-off, which is like, I think it's like a standard machine learning problem between accuracy and expressiveness. If you want designers basically, or user designers, or interface designers to understand your model, then the models has to be expressive. Machine learning model has to be expressive, which is rarely the case. If you want to use neural network, then they'll, for instance, less expressive than random forest. So you have to pick and choose, and you have to take accuracy versus expressiveness into account. There's also kind of a trade-off between the generalization and specific game. So if you want to do like general model, like that understand human emotions regardless of the game they're playing or of the interface they're using, then the model obviously will be of less accuracy than if it is specifically designed for a specific use case. Unified player experience model, however, are possible. So if you have lots of data, it's usually the case for every machine learning models. More data, more accurate results. This also applies for emotion. And finally, the obvious case is that the main purpose of understanding emotions is to bring in new understanding of humans and new way of interacting with the humans and personalized content. Machine doesn't have to respond to us in the same way regardless of who we are. They have to understand how we feel and how we act and what is our emotional state. And I believe this is crucial for the next generation of AI and machine learning. That's it. Thank you.